the derivative of the electric potential. Okay, so graphically, if you have remember those charged conductors? So let's say this is a charged conductor. Charged conductor. So where is the charge? It's a sphere. Where's the charge? On the surface. So all the little charges are on the surface, like it has chickenpox. I'm just kidding. Okay. Measles. Just kidding. Okay, so it's got all the charge on the surface. So when we were graphing electric field versus distance, and let's say that the radius of this thing is A. I don't want it to get confused with the variable R. So this is my R axis. This is my electric field axis. What's the electric field inside this charge? 0. So inside this charge, I'm going to make it look, there we go. So that's 0. Then what is it from A to infinity? Right, it looks like a 1 over, I'm going to put an asymptote right there. So something like that. So the electric field is proportional to 1 over r squared. That's a great thing to write if you're trying to draw something and you don't know if it's coming out the way you want it to look. You can always make a note that it's a 1 over r squared or proportional to 1 over r squared or something like that when you draw it. So now what about the electric potential? If the electric potential so what about inside though? It's constant. Very good. So I would write, maybe it's something like this. Till we get to point A, and then what would my graph look like? Would it start up here, at the line, or below the line? At the line. Very good. And there it goes off to asymptotic land, and you could then write that this is proportional to 1 over r if you wanted to show that they are different. But those two go together. They're BFFs. What do you think about that? That's what makes looking at these graphs tricky. If you're not careful, you'll read the question and think it's about electric field. You'll pick the electric field version of the shape, and it was really electric potential, or vice versa. So make sure that you read those multiple choice questions carefully. And I plan on giving you some slightly mixed multiple choice like on quiz so that we can differentiate from the two graphs. What's up? So how much work do you do moving a point charge from here inside the sphere to here inside the sphere? Why is it 0? Because isn't work like change in potential energy, or QV? Was there a change in V? No way. So it's like you just took your books and slid them along the tabletop. There was no work done by the gravitational field in that movement. What do you think?